Welcome to SDN Tech Networking Podcast, world's first human-curated AI podcast.
Okay, so today we're going to be diving into something pretty fundamental
Okay.
to how our digital world works.
Mhm.
Like making sure everything's on time.
Yeah.
You've probably heard of NTP, for keeping computers synchronized.
Right.
But have you ever heard of PTP?
PTP, yeah.
Precision Time Protocol.
Uh-huh.
It's kind of like NTP,
Yeah.
but it's on a whole other level of accuracy.
Oh, yeah.
We're talking nanoseconds here.
Wow.
So in this deep dive, we're going to try to understand what PTP is,
Okay.
why it's so important in certain fields, and then what you as a network engineer need to know to work with it.
Yeah, so what's really fascinating about PTP is that it addresses a need for incredibly precise timing.
Okay.
And this is in applications where even the slightest discrepancies can cause major issues.
Oh, wow.
So think about financial transactions that
Yeah.
need to happen in microseconds, or telecommunications networks where timing errors can lead to dropped calls.
Oh, right.
PTP is designed to handle these really high-stakes scenarios
Absolutely.
with incredible precision.
So it's not just about making sure that my computer clock is
Right.
showing the right time.
Exactly.
It's about making sure that an entire system,
Yes.
often, distributed across a network,
Mm-hmm.
are all operating at the same time down to the nanosecond.
Perfectly in sync, yep.
Wow. Okay.
And that's where PTP's primary function comes in.
Okay.
It distributes both time and frequency information
Okay.
across the network.
Okay.
So unlike NTP, which focuses solely on time,
Right.
PTP makes sure that all the devices are not only synced to the same time,
Uh-huh.
but they're also operating at the same frequency.
Oh, interesting.
So imagine an orchestra where not only do all the musicians need to start at the same time,
Right.
they also need to be playing at the same tempo.
Okay.
That's the level of coordination we're talking about.
That's a great analogy.
Yeah.
So how does PTP actually achieve this level of accuracy?
Yeah, so PTP uses a combination of clever techniques to achieve this.
Okay.
One key difference from NTP is the use of hardware timestamps.
Okay.
So while NTP relies on software timestamps, which are recorded by the computer's operating system,
Right.
PTP timestamps are actually recorded directly by the network interface card
Oh, wow.
at the physical layer.
Okay.
And this eliminates a significant source of delay and variability.
So it's kind of like cutting out the middleman
Exactly.
and getting the time directly from the source.
Yes.
Does this mean that specialized hardware is always needed for PTP?
It's yes and no.
Okay.
While PTP relies on hardware support for that, optimal performance,
Uh-huh.
some implementations can work with software timestamps,
Okay.
but the accuracy will be reduced.
Gotcha. Okay.
But even with hardware timestamping,
Yeah.
PTP's precision comes from a multi-layered approach.
Okay.
It uses a master-slave architecture
Right.
where a designated grandmaster clock dictates the time for the whole network.
Wow. Okay.
And it employs very sophisticated algorithms to constantly monitor and adjust for any discrepancies in timing.
Okay, so we've got this grandmaster calling the shots.
Yes,
Everyone else is following their lead.
exactly.
But you mentioned different types of clocks.
Yeah.
How does this whole system of clocks work?
It's actually a really fascinating hierarchy.
Oh,
A bit like a well-organized company structure.
okay.
You have your grandmaster clock at the top,
Right.
the ultimate authority on time.
Okay.
Often this is synchronized to an extremely precise external source, like an atomic clock.
So this is like the CEO
Yeah.
making sure the whole operation's running smoothly.
Precisely.
Okay.
Then you have your ordinary clocks,
Okay.
which are your everyday devices like computers and servers.
Right.
They're syncing their time to the grandmaster.
Okay.
Think of these as the employees diligently following the CEO's directives.
Gotcha.
And then we have the boundary clocks that we talked about
Right.
earlier.
Right.
These are like middle management
Yeah.
responsible for relaying the time information
Okay.
between different segments of the network,
Uh-huh.
ensuring that everyone stays in sync, even across geographically dispersed locations.
That makes sense.
Yeah.
So we've got this hierarchy of clocks all working together to maintain accurate timing across the network.
Right.
But how does the network decide who gets to be the grandmaster?
That's where the best master clock algorithm comes into play.
Okay.
BMCA.
BMCA.
It's like a democratic election process
Interesting.
where each clock broadcasts its capabilities and qualities.
Okay.
So things like accuracy, stability, priority.
Uh-huh.
And the network automatically selects the most qualified clock to be the grandmaster.
So it's not just about having the fanciest clock.
Exactly.
It's about having the one that's the most trustworthy and reliable.
The most trustworthy, yes.
Okay.
So the BMCA ensures that the network always has the best possible time source.
Right.
Even if conditions change or new clocks are added. It's a really clever way to maintain stability and precision in a dynamic environment.
That's super interesting. Okay.
Yeah.
So we've established the PTP is incredibly precise.
Yeah.
And it relies on this hierarchical system of clocks with the democratically elected grandmaster.
Right.
But how does this translate to the real world?
Yeah.
What are some of the applications where PTP really shines?
Well, as I mentioned before, telecommunications is a big one.
Okay.
So mobile networks, especially 4G and 5G,
Mm-hmm.
they rely heavily on precise timing for synchronization
Yeah.
between the base stations and devices.
Right.
Even tiny discrepancies
Yeah.
can lead to dropped calls, interference,
Uh-huh.
and reduced data rates.
Okay, so PTP is essentially keeping our conversations flowing
Yes.
and preventing those frustrating failed messages.
Exactly.
Yeah.
Another area where PTP is indispensable is financial trading.
Oh, right. Yeah.
High-frequency trading algorithms depend on split-second timing to execute trades.
Wow.
Any delay can mean the difference between profit and loss.
Yeah. Talk about a high-pressure environment.
Yeah.
It makes sense that they would need the most accurate timekeeping possible.
For sure.
What other applications rely on PTP?
Well, the power grid is another great example.
Okay.
As we transition towards more renewable energy sources,
Right.
the grid is becoming much more complex and dynamic.
Yeah.
PTP helps to synchronize all the various components of the grid,
Okay.
ensuring efficient energy distribution and potentially preventing blackouts.
So PTP is not only keeping our financial markets humming,
Yeah.
but it's also keeping our lights on.
That's right.
That's pretty impressive.
It is.
It doesn't stop there.
It doesn't stop there.
Okay.
PTP is also gaining traction in multimedia applications.
Okay.
Think about live streaming, video conferencing, or even just watching a movie online.
Right.
PTP ensures smooth playback
Okay.
and prevents the audio and video from going out of sync.
I'm starting to see how PTP is subtly influencing so many aspects of our digital lives.
It's everywhere.
It's like the unsung hero of the digital world,
That's a great way to put it.
working behind the scenes to keep everything running smoothly.
Yeah, it's a foundational technology that often goes unnoticed,
Yeah.
but its importance is undeniable.
Right.
As we move towards an increasingly interconnected world,
Yeah.
PTP's role is only going to become more crucial.
Okay. Well, we've got a solid understanding now of what PTP is, why it's important, and even some of the specific applications where it shines.
Yeah.
But let's shift gears a bit and focus on our network engineer listeners.
Okay.
How can they tell if their network is ready for PTP?
Yeah,
What are the key things that they need to check?
that's a great question.
Yeah.
Let's start with the basics. Hardware support.
Okay.
So they need to check if their network interface cards,
Okay.
the NICs,
NICs.
and their drivers
Right.
support hardware timestamping,
Right.
which, as we've established, is crucial for achieving PTP's nanosecond accuracy.
So step one is figuring out if their hardware is up to the task. What's the best way to go about doing that?
Well, luckily, there's a simple command line tool called ftool
Okay.
that can help them do just that.
Okay.
It's readily available on most Linux systems
Gotcha.
and can provide a wealth of information about network interfaces, including their timestamping capabilities.
Okay.
It's a powerful tool that every network engineer working with PTP should be familiar with.
So firing up a terminal and running a quick ftool command is a good starting point.
Yes, very good starting point.
Okay, what other things should they be looking for to assess their network's PTP readiness?
Beyond hardware support,
Yeah.
they need to consider things like network latency and jitter.
Okay.
So remember, PTP relies on the precise timing of messages exchanged between clocks.
Right.
So any delays or variations in latency can impact accuracy.
Okay, so a fast and responsive network is essential for PTP to function properly.
Absolutely.
Makes sense.
They should analyze their network topology,
Okay.
identify potential bottlenecks,
Hmm.
and consider implementing traffic shaping or quality of service mechanisms
Right.
to prioritize PTP traffic
Right.
and minimize latency.
So it's not just about having the right hardware.
It's not just the hardware,
It's about optimizing the network environment
the whole network.
to ensure that PTP can operate at peak performance.
Exactly.
Okay.
And of course, security should always be a top priority.
Right.
They need to implement measures to protect their PTP network from malicious attacks,
Okay.
just like they would with any other critical infrastructure.
So things like authentication, encryption, access control,
All those things, yep.
all those things are crucial to safeguard the integrity of the PTP system.
Absolutely. A well-secured PTP network is a robust and reliable one.
Okay, that's a great starting point for our network engineer listeners.
Yeah.
We've covered the basics of checking hardware support,
Right.
considering network latency and security,
Right.
and using tools like F-Tool for diagnostics.
Yes.
But there's always more to learn,
Always.
especially when it comes to the practical aspects
Yeah.
of working with PTP.
Yeah.
So in the next part of our deep dive,
Okay.
we'll delve into those details and offer even more insights and tips for getting the most out of PTP.
Sounds good.
Welcome back.
Yeah. Welcome back.
So we've laid a good foundation. We're understanding that PTP is all about this precision timekeeping.
Mm.
It relies on specialized hardware, this hierarchy of clocks.
Right.
Now, I'm curious about the actual implementation.
Yeah.
Let's say I'm a network engineer.
Okay.
I've confirmed that my hardware supports PTP.
Mm-hmm.
What are the next steps in getting it up and running?
So that's where the rubber meets the road.
Okay.
Once you've got your hardware verified.
Yeah.
The next crucial step is configuring your PTP settings.
Okay.
This is where you define how your clocks behave
Gotcha.
within the network.
Right.
Think of it like setting the rules of the game for your PTP ecosystem.
Okay, so what kind of rules are we talking about here? What are some of the key settings that I need to be aware of?
Yeah. One of the most important is the domain.
Okay.
This defines a logical grouping of clocks that are meant to be synchronized.
Uh-huh.
It's like assigning different departments within your organization,
Okay.
each with their own timekeeping system,
Right.
but ultimately aligned with the company's overall time.
So I could have different domains for, say, my finance department
Exactly.
and my manufacturing plant,
Yeah,
each operating on PTP, but with some level of separation.
precisely.
Okay.
This allows for flexibility and isolation,
Okay.
ensuring that specific areas of the network can maintain their own time synchronization without interfering with other domains.
Gotcha.
Another key parameter is the priority setting.
Okay.
And this comes into play during the best master clock algorithm election we talked about earlier.
Right. The democratic process of choosing the grandmaster clock.
Exactly.
So this priority setting allows me to influence which clock is more likely to get elected.
Exactly. It's a way to assign weight to certain clocks based on their importance or reliability.
Okay.
So, for example, a clock connected to a highly accurate external time source, like GPS,
Right.
would typically be given a higher priority
Okay.
than a clock relying on a less stable internal oscillator.
That makes sense. You're essentially rigging the election in a good way
Yes, you are.
to ensure
Yeah.
that the most qualified clock gets the top spot.
The most qualified clock gets the top spot. That's right.
Are there any other settings that I should be aware of when configuring PTP?
Another important one is the announce interval.
Okay.
This determines how often clocks broadcast their time and status information
Okay.
to the network.
Mm-hmm.
So a shorter interval means more frequent updates,
Okay.
leading to tighter synchronization,
Right.
but also increased network traffic.
So it's a trade-off between accuracy and network load.
Yeah, exactly.
I guess it's about finding the sweet spot that balances both,
Uh-huh.
depending on the specific needs of the network.
For sure. These are just a few examples.
Yeah.
There are many other parameters that can be fine-tuned.
Okay.
But understanding these basics
Yeah.
is essential for anyone starting out with PTP configuration.
Okay, I'm starting to get a feel for the level of control I have as a network engineer when implementing PTP.
Yeah.
But how do I actually go about setting these parameters?
Right.
Is it a manual process on each device?
So that depends.
Okay.
There's a couple of approaches.
Okay.
You can configure PTP directly on each device,
Yeah.
either through its web interface or command line interface.
Right.
This gives you granular control,
Oh, okay.
but it can be tedious, especially for large networks.
I can imagine that would get pretty cumbersome if you're dealing with dozens or even hundreds of devices.
Exactly.
Is there a more streamlined approach?
Yes, thankfully,
Mm.
many network management systems
Mhm.
offer centralized PTP configuration tools.
Okay.
These allow you to manage PTP settings across your whole network
Okay.
from a single interface. You can define profiles, apply templates, and automate many of the configuration tasks,
Okay.
making life much easier for network engineers.
That sounds like a much more scalable and efficient approach.
Yes, it is.
So we've talked about configuration,
Mm-hmm.
but what about monitoring?
Right.
How do I keep tabs on how well my PTP network is actually performing.
Yeah.
Are there any specific tools or techniques
Yes.
that are useful for PTP diagnostics?
Absolutely.
Okay.
Monitoring is crucial
Right.
to ensure that your PTP network is operating correctly
Okay.
and to identify any potential issue before they cause problems.
Right.
So remember that handy ethtool command we mentioned earlier?
Yes.
Well, it can also be used to retrieve PTP statistics
Oh,
from your network interfaces,
Oh.
like the current offset from the grandmaster clock,
Right.
the number of PTP packets received and sent, any errors encountered.
So ethtool is a multi-purpose tool.
It is.
Not only can it be used to check hardware support, but it's also helpful for ongoing monitoring and troubleshooting.
Precisely.
Okay.
It's a great tool for getting a quick snapshot of your PTP network health.
Okay.
But for more comprehensive monitoring, you'll likely want to use a dedicated PTT monitoring tool.
Okay.
These tools provide a centralized dashboard where you can visualize the clock hierarchy, track performance metrics like latency and jitter, and set up alerts for any anomalies or deviations from your defined thresholds.
Well, so that's like having a control center for your PTP network.
Yes.
Where you can keep an eye on everything.
Keep an eye on everything.
And get notified if anything goes awry.
That's right.
Okay.
And some of these tools even offer advanced features like root cause analysis.
Oh, wow.
Helping you pinpoint the source of any timing issues and resolve them quickly.
Wow. So you can really get into the nitty-gritty details of PTP performance with these tools.
You can.
That's quite impressive. It seems like PTP offers a lot of flexibility and control.
It does.
To network engineers who know how to use it.
It does, and with the right tools and a solid understanding of the underlying concepts. Managing a PTP network can be efficient and even, dare I say, enjoyable.
Okay, well, we've covered a lot of ground in this section.
We have.
From the basics of PTP configuration to the importance of monitoring and the tools that can help.
Yeah.
But I feel like we've only scratched the surface
Oh, yeah.
of what's possible with PTP.
There's so much more.
Well, perfect.
Yeah.
Let's dive into that in the next part of our deep dive.
Okay.
Stay tuned to uncover even more fascinating aspects of this time-bending technology. Welcome back to the final part of our PTP deep dive.
Back again.
So we've explored what PTP is, why it's important, how it works.
Yep.
From hardware requirements to configuration and monitoring.
Right.
But I have a feeling there's still more to uncover.
There's always more.
Especially for those who really want to push the boundaries of precision timekeeping.
Uh-huh.
So let's talk about the future of PTP.
Okay.
What are some of the cutting-edge developments
that
network engineers should be aware of?
Well, one of the most exciting developments is the rise of White Rabbit technology. White Rabbit.
Okay.
It's essentially PTP on steroids.
Okay.
It uses fiber optic cables to distribute both time and frequency signals with exceptional accuracy and stability.
Wow. So we're talking like sub-nanosecond precision and ultra-low jitter.
Yes, exactly.
Wow. That sounds incredibly precise.
It is.
What makes White Rabbit so much more accurate than traditional PTP?
So it comes down to a few key factors.
Okay.
First, fiber optic cables are inherently less susceptible to interference than copper cables.
Right.
This reduces noise and improves signal integrity.
Okay.
Second, White Rabbit uses sophisticated hardware and algorithms to compensate for any remaining delays and variations in the fiber itself. So this ensures incredibly tight synchronization.
So it's like taking the precision of PTP and adding this layer of refinement to eliminate even the tiniest imperfections. Where is White Rabbit being used today?
So primarily it's found in applications where even the slightest timing errors can have significant consequences.
Okay.
Things like scientific experiments, telecommunications networks, and high-frequency trading platforms.
So like particle accelerators that need to synchronize beams with like sub-nanosecond accuracy.
Yeah, or financial institutions executing trades where microseconds can mean millions of dollars.
Right. Yeah, it makes sense.
Big stakes.
It sounds like White Rabbit is really pushing the boundaries of what's possible.
It really is.
With time synchronization.
It is.
Are there any other advancements in PTP that are worth mentioning?
Another area that's gaining traction is the integration of PTP with something called time-sensitive networking, or TSN.
TSN.
It's a set of standards that are designed to transform traditional Ethernet networks into deterministic, real-time communication systems.
Okay, break that down for me.
Right.
What does deterministic mean in this context?
It means that TSN guarantees the delivery of data packets within a specific time window every time. This is crucial for applications that require real-time control and coordination, like industrial automation, robotics, and autonomous vehicles.
So TSN is all about bringing predictability and reliability to time-critical applications.
Exactly.
How does PTP fit into this picture?
So PTP provides the precise time synchronization that TSN relies on to orchestrate the delivery of those data packets. It's like the conductor of an orchestra. It ensures that every instrument plays its part at exactly the right time, resulting in a harmonious performance.
That's a great analogy.
Yeah.
So PTP and TSN are working together to create a more deterministic and reliable network environment.
They are.
Especially for applications where timing is everything.
Absolutely.
As these technologies continue to mature and converge, I can only imagine, like, even more innovative applications will emerge.
I think so.
Blurring the lines between the physical and digital worlds.
For sure.
So to wrap things up, what are the key takeaways you want our listeners to remember from our PTP deep dive?
So first and foremost, I think, PTP is a powerful technology. It's essential for a wide range of applications, and its importance will only continue to grow as our world becomes increasingly interconnected and reliant on precise timing.
So it's not just about making sure our clocks show the right time.
Exactly.
It's about enabling a whole ecosystem of time-sensitive applications to function seamlessly and reliably.
That's right.
Okay, what else?
Second, PTP is more than just accuracy. It's also about reliability, scalability, and security. So implementing PTP effectively requires careful consideration of all these factors, from choosing the right hardware to configuring settings appropriately and ensuring robust network security.
So it's not just a set it and forget it technology?
It's not, no.
It requires ongoing attention and expertise to ensure optimal performance.
For sure.
And lastly,
PTP is a dynamic and evolving field. New technologies like White Rabbit and time-sensitive networking, they're pushing the boundaries of what's possible with time synchronization, opening up a world of possibilities for innovation and efficiency.
Sounds like network engineers who embrace PTP and stay ahead of these advancements will be well positioned to tackle the challenges and opportunities of our increasingly time-sensitive digital landscape.
Absolutely.
Well, thanks for joining us on this deep dive into the world of PTP.
It's been a pleasure.
I hope you found it insightful and maybe even a little bit mind-bending.
I hope so too.
Until next time.
Yeah, see you next time.
May your clocks always be in sync.
Always be in sync.